Good afternoon, all. Thank you for joining our today's webinar in Advanced Simulation and Waveform Analysis in Altium Designer. I'm Sairan. I'm working as Team Lead EDF for Altium products here at PSAT Microsystems. Today's session is recording. If anyone having any questions during the presentation or during the demonstration, please type your questions in the chat. We'll discuss at the end of the presentation. Now, let us get started. Yes, in today's webinar, we're going to discuss about the Monte Carlo and sensitivity analysis, which is a new feature implemented in the Altium latest version, and followed by working with the plots and measurement cursors, and also we're going to discuss about the mathematical expressions, followed by working with the measurement results, and we're going to demonstrate all these features, and followed by summary and the Q&A. First, let us have a look at the Monte Carlo and the sensitivity analysis. Monte Carlo mode analysis, the effect of random changes of parameters of the selected components according to the selected distribution type, where you can able to have different values of the components with respect to the tolerance, and then you can see what the behavior in the waveforms by using this analysis. And also, Monte Carlo analysis requires the following parameters: number of runs, that means number of simulations, and the distribution. That means distribution type. What is the distribution type you want? As uniform or Gaussian or worst case. And the last parameter required for this Monte Carlo analysis is the tolerance. That means maximum deviation from the parameter value what you have specified in the your design. And when it comes to sensitivity analysis, sensitivity analysis provides a way of determining which circuit components or factors have the most influence on output characteristics of a circuit. With this information, you can reduce the influence of negative characteristics or alternately enhance the circuit performance based on the positive characteristics. Sensitivity analysis calculates sensitivities as numeric values of given measurements related to components, model parameters of circuit components, as well as sensitivity to temperature or global parameters. The result of the analysis is a table of the ranged values of sensitivities for each measurement type. There must, to perform a sensitivity analysis, there must be a suitable measurement configured in the image you're seeing the right side. The AC sweep analysis has an output expression setup, dB V output, and this output has two measurement configured, BW, we can call it the bandwidth, and max, that means maximum amplitude. The sensitivity can be calculated for either of these measurements. To analyze the sensitivity, enable the sensitivity option in the simulation dashboard as shown. Then click on the settings icon to open the advanced analysis settings dialog where the sensitivity options can be enabled on the sensitivity tab of the dial. Now I'm going to show you this one how you can enable and how you can perform the analysis by using a small demo during the demonstration. Now let us discuss about the working with plots and measurement classes. You can see here in Altium where you can have a different output waveforms. You can able to get it in terms of V output or V input. We can have a different charts or plots or waveforms can be created, and you can able to move the waveform from one plot to other plot, and you can able to completely configure these plots. That means grid lines and line styles based on requirement, which we will going to review during the demonstration how you can customize this. And we can set two cursors simultaneously and move them along with the x-axis. The coordinates of the intersection of the cursor and the plots are displayed in the lower part of the window. Measurement details are displayed in the sim data panel and can be also displayed below the plot. To configure this, right click on the plot and select the chart options. Use the right click cursor of command to remove the cursors. Once you have the waveform by using this, adding the cursors again, you can able to the measurements of your wave. Now let us see about how we can able to create a mathematical expressions of your waveforms. The iterative waveform dialog can also be used to determine a mathematical expressions. You can build the expression by selecting the waveform. It will be included in the expression field when you click on it in the waveform list. After the required function, then continue to select the waveforms to build up required expression. Use the name field to give your expression a meaningful name. In addition to, you can change the units and color of the displayed waveform. Now let us discuss how we can work with this measurement results. Measurement results are a collection of quantities that characterize the behavior and quality of the circuit. The value of the measurements are calculated according to the specified values by evaluating the characteristics of the waveform in the circuit. Examples of measurements include bandwidth, gain, rise time, fall time, pulse, speed, frequency, and period. There are no limits to number of measurements you can define for a signal. Reference for list range of measurement types. Select the required measurement from the type list like measurement statistics. Measurement statistics are calculated automatically and displayed in the lower region of the sim data panel. And we have got data measurement results in a table. A full table of measurement results can be displayed in the main SDF window by clicking the expand the table link in the sim data panel. And also we have a option to copy the table to the spreadsheet. And also we can see the histogram results, which will visualize the distribution of data by generating a histogram directly from the measurement results. Over the cursor over the image about the you can able to see this is the where you can able to get the histogram results. For example, if a parameter shift has been performed where two components values has been saved, these can be plotted against each other. You can see here. Okay, like this you can able to perform this different kind of measurement results you can able to get by using the Altium designer input simulation capabilities. This is how we can able to add a different measurements apart from the what and all currently we have just right click on the waveform and you can just go to edit and then here you can able to click to add a additional measurement to perform it on your existing waveform. Now let us see with a small demonstration how we can able to perform the Monte Carlo sensitivity and measurement like different measurement options, mathematical expression how we can set for your outputs. Let us go through with a small demonstration with help of Altium Designer. Here I have opened a example file where I'm going to showcase you all the options which we have discussed in the presentation. Yes, we all know we have a simulation feature available in the team. During my last webinar, I have showcased you how we can install the simulation, how we can perform the basic simulation. Now we are going to perform some advanced level simulations. As you are aware, once the simulation extension got installed, just access from here. We have a simulation dashboard where you can able to perform the simulation. I think we had discussed about this option during the last webinar, which you can enable you to perform the simulation on a particular document or an entire project. You can able to choose to first with the start verification. The start verification help you to identify are there any IC errors in the schematic circuit, are there any components having missing model files. Yes, we have a few components where the model files are missing and we have got a message from RTM stating that would like to auto assign for passive components. Yes, I'm happy to assign it. Just click on assign. Next up, we have got the preparation. The preparation tool has automatically recognized the voltage sources V1, V2, and V, and we can see we have two negative and positive voltages followed by a V pulse signal. And if you have option to add probes like voltage, current, power, and voltage difference probes, if you want, you can able to add into the circuit. And followed by we have got different types of analysis: operating point, DCSP, transient, and ICSP. If you look at the transient, we have got different output percent input output. In the output, we have got two different measurements. We have mentioned minimum and max. So if you want to add any additional measurement value, just go to the measurements and you can able to click on add a measurement. And here I would like to have a measurement for frequency. Just enter the frequency, and from the drop down, select the type is a frequency, and just click on create. So you have got the three measurements for this output expression. And also, if you want to, can have a different output expression for AC speed for the output. We have got magnitude output. I want to have a different uh, thing for measurement for this one. I would like to add measurement, and I will just say it has a max response. What is the maximum response of the circuit I want to see? And here it is max. Okay, you just create. See, now the response has been created. Okay, now let us do some analysis with the help of transient. Just enable the transient analysis. We have got input and output the different measurement results. Just click on, if you want to adjust this value, you can adjust. Just click on the analysis. Yes, we have got the waveform generated. V input, where it's wave, and V output, we can see we have got a gradual increase in the sinusoidal signal. And if you go to the panels sim data, where you can able to see the different kinds of what is the waveforms you generated and what is the rise time, fall time, you can able to see here. If you go to the this measurement window, we have created some few measurement uh, options for the output waveform. We have seen under V output, we got maximum. We have the maximum at this is the voltage. You can see here what is the maximum values. We have maximum is 2.489, and the minimum all we can see different values in terms of maximum. If you click on showing chart, you can see this is the maximum output of this your signal, which is 2.849. If you say minimum, you can just click on show on chart. It will try to display this is the minimum where it is able to highlight. And also, if you want to see the frequency, if you want to see here, show on chart, you can see here frequency is then very at the beginning of the signal. Suppose if you want to see what the frequency response of your signal, you can adjust this. Just right click on this, just go to edit waveform and go to measurements, and here you can able to mention the at what time frame you want to identify the frequency response. Just enter that time frame. I want to identify at 7.5 milliseconds to 12 milliseconds. What is the my frequency response, which means time frame I want to have it. Just click on create and then set this waveform, and just click on short. You can able to see the waveform 7.5 milliseconds to 12 milliseconds. What will be the your frequency response you can able to see in this uh, measurement window. This are you can able to see different measurement results inside the Altium designer simulation tab in the data. Yes, now I'm just again going back to the simulation dashboard. Now we are going to perform the Monte Carlo analysis here for the ACSP, and we can see we have got different analysis available like temperature sweep analysis, Monte Carlo, and sensitivity. Sensitivity, we are going to showcase you after this Monte Carlo analysis. Now just select the Monte Carlo analysis and just click on settings. You can able to set the what is the number of runs you want to perform and distribution, and what is the tolerance value to take with respect to maximum tolerance value to take and maximum value to take with respect to the current existing value of the component. Just need to mention this one, and just click OK, and just perform the analysis. Now it's going to perform the analysis with respect to the different values of the components inside your design, and it will going to show the outputs in the waveform. If you click on here V1, you can able to see the what is the value it is taken into consideration to plot this outputs. You can able to see inside the Altium design. And if you want to have more runs, as we have only run 20 runs. If you want to have the more runs, let us say 40, you can just go to the simulation dashboard and then go to settings, and you can able to change the things to 40 and click OK and perform the analysis. Now it will perform the analysis for the 40 runs with the different values. 1, 2, you can, if you scroll down, it will be 40, 20, 24, 26, 40, like this, you can able to have the outputs. And if you go to the measurement window, we can see we have the max, maximum response, maximum. You can see what's the minimum, what's the maximum. You can see different values of your this particular value. And also we can get the histogram by selecting histogram from the sim date and sim data panel. Just click on the what click OK to create the histogram. Histogram shows the percentage of the on the y-axis. It shows us how much time if we will percentage the variation that the given value on the x-axis within the range. So this is the other way to visualize the impact of randomization. By the histogram, you can able to see the impact of your circuit in terms of percentage levels, which is possible with help of the Altium designer. When you to see results in the histogram values as well. Now we are just going to do some changes. This time we have performed the analysis distribution in the terms of uniform. Now let us see how we can able to perform the worst case analysis of your design. Just click on worst case and mention the number of nodes you want. Just click OK and then to perform the analysis. You can see we have got a wide range of analysis of the worst case distribution. Okay. This is the worst case analysis of your design, how you can able to perform easily with this Altium designer input simulation capabilities. Okay, this is how we can able to perform the Monte Carlo analysis inside the Altium designer. Now let us perform some analysis using sensitivity analysis. Just sensitivity analysis, as we have explained, which component is affecting your output. Your circuit can be calculated by the sensitivity analysis. Now I'm going to perform sensitivity analysis, and I'm going to use it transient for sensitivity. Let us enable this and go to settings, and in the settings we have to go to sensitivity and enable the group deviation, and here for register it is 1 million steps, and we are not going to highlight any component we want to perform for all. Okay, I want to perform it for all and click OK and perform the analysis. When perform the analysis, like in Monte Carlo, it also perform give you the different waveforms for the depend upon the number of milli steps we specified for the components, and it will give you the values. It is similar to the Monte Carlo analysis. Now, if you go to the measurements, we can select the maximum, and we can see have again the sensitivity under maximum, but which component is affecting as the output. Here you can see in terms of all the components, C2 is affecting in terms of negative. You can see when compared to all the components, this having more negativity, which will be affecting the output of the circuit in terms of maximum measurement value in terms of output. And if you look at the minimum, if you click on sensitivity, again, the same component C2 having more negativity, which will be affecting the output of your design in terms of minimum voltage value, minimum output. When you look at the frequency, in terms of frequency, here all are almost same, but here in terms of frequency, we are getting affected most of thing by R2, but C2 also is in picture. So that how to overcome, I think I explained within the thing, we have to change the positivity of the circuit, which will reduce the effect of our output. But here in this case, we are getting most affected by the in terms of maximum is by C2. And if you want to see a plot, you can able to have it for a component C2, and you can able to see here there is a kind of you can see it's a geosymmetric line which will show the how much it is been affecting the output where you can able to see inside the Altium designer in terms of sensitivity. Now, this how we can able to perform the sensitivity analysis with help of the Altium Designer simulation capabilities. Now, let us jump into the next thing where we can able to add different waveforms and how we can plot different waveforms. Let's have a look. Now let us me perform the target analysis. Here I have got input and output. Here I want to have the input in a different plot and output in different plot. How can you do it? Just right click, just add a plot and just mention what is the type of the plot you want to have it. Just mention it as a input and click on next and next. Finish. We have created a new plot. Just drag and drop the plot which you want to have it in the bottom plot. You can see here according to the plot got adjusted based on the waveforms. We have an input V output here and we have got the V input here. Okay, suppose you want to add any cursors, right click on this, add cursor here. We can right click on this cursor, we be able to see the cursors adjusted between the locations. And if you go to the general, you can able to see what is the uh, differences and RMS and frequencies and rise time, fall time. Everything can be seen under the mentioned cursor options. If you have the cursors here, just if you want to have, if you want to hide this one, just select it and we would add it plot options. Okay, like this, be able to have that different measurement options, measurement cursors you can add it to the designer. And if you want to add any mathematical expressions to the output waveforms, also you can able to add it. Just if you want to add anything, just right click on this waveform, edit wave, or just double click on the waveform to add any mathematical expression to this one. Just I want to have, you want to have add a different thing and different what not functions you want to add. If you select from here, I can able to choose from here as well. I want to have it a absolute value for this one, for this for the affliction. Just I just mentioned ABS. Just keep and you can use the name from as rectified or rectified and click OK. You can see here it's been rectified as per the absolute value. And this waveform can be stored as per our requirement. Just go to tools, store waveform, and you can able to store this waveform. Yes, waveform is stored successfully. And if you want to see what exactly the waveform, how it looks, you can able to open by using this notepad. I just you can able to see what is the feed by the notepad. This is how your waveform data looks inside, how you will see the data uh, in the oscilloscope. The values can be seen here. If you want to change any value, you can change it and you can able to file and you can able to save the same inside the you can able to save this waveform for further review. Okay, and also there's a new capabilities. These are a kind of a new capability where you can save the waveform. And also there is a one more new capabilities where you can use this waveform as a input to this signal. You can see here we have a pulse here. Instead of pulse, you want to feed the particular signal. Just click on here. Now click and you to add this waveform to this one. You can able to perform the analysis by using a different output with the new capabilities available inside the Altium design. The key point is that you can make a mathematical manipulated waveforms, simulation just from other portal systems, and even capture oscilloscope waveforms and use them as stimulus for further simulations. These are the new capabilities where you can use this uh, waveform simulations as input to your circuit and you can see the outputs. This is all about the advanced simulation and waveform analysis in Altium Designer. Yes, now come to the summary. Uh, yes, to summarize this, we have discussed about the different measurement results, and part by we have discussed about the Monte Carlo analysis, sensitivity analysis, and we have discussed about how we can work with the plots and measurement cursors we have discussed, and followed by mathematical expressions, and also we have discussed how we can save the waveform and how we can use this saved waveform as input to your output. Yes,